Alright, so today I'll be going over the simulation project or flight simulation project that we did as part of our stability and controls class for aircrafts. If you're not interested in that kind of stuff, aircraft controls, click away. But this is basically going over what we did exactly. We worked in the software simulation in Simulink with MATLAB supported. So yeah, so our aircraft is based on the Boeing 747-200 United Airlines. This is just a model I just took from Sketchfab. Yeah, so here you can see the specifications for it. You know, your Mach number, mean aerodynamic chord, wing reference area, all the typical stuff. So it's top view, front view here, some side view there. So basically for this simulation project, we made a couple assumptions. I mean, that's what you have to do if you want to make a rigid 6-degree of freedom model for an aircraft. So some assumptions we did make was perfect sensors. So you're going to see that reflected in the model. Another thing we said was that the thrust, all the forces and thrusts produced by each engine is going to be only in the x direction. What that basically means is if the plane, let's say the plane's in steady level flight, and then we have a right hand roll. This is kind of a way to visualize it. Right hand roll, right? Everyone knows this. But you have your x direction going here, y going out of the page basically, or out of the screen, and then you have your z direction going down. So we're assuming all the thrust forces are going in this direction. There are things called where engines, they may be slightly angled or they may be able to move in terms of the orientation. We're assuming its fixed position as well as it's in parallel. So here's the entire simulation, right? It looks like a bunch of blocks that mean nothing, right? But let's break it down slowly so we kind of understand it. So let's start off with what we would typically know for an aircraft, right? It takes pilot commands, either manual, semi-autopilot, or fully autopilot. So let's go into this block right here. Okay, so you have accept flight plan commands, sub guidance, sub control commands. The control commands here is basically your manual control, right? This is what we worked in the project most of the time, where you input some kind of command and then you look at the aircraft's response. So that can be pitch rate, roll rate, yaw rate, its airspeed. So that kind of stuff you look at to kind of evaluate its performance, and that's something I'll touch upon later. But some things you probably know. So pitch, if a positive pitch angle, right, you nose up, and the negative pitch nose down. And then roll, obviously when you're rolling, you're moving your wings up and down like this. So a positive roll, you're gonna roll to the right, negative roll to the left. But yaw, that's just kind of a way for it to change the side slip. And then horizontal stabilizers, that's functions similar to pitching up and down. It's a control surface. And then your throttle command, obviously that can affect pitch and also the vertical force. So for the purpose of our project, we did not go over a spoiler or a toe brake, but that's something you could do. Yeah. Okay, so navigation model right here, we don't have anything for this. This is something my professor just left in here for improvement. You have your aviate block here. I'll touch on that later. Let's go over the physics of the model, which is in the forces and moments. So here, obviously, your plane, to kind of encapsulate all of the movement of the plane, you have to break it down. So you're breaking down here in terms of longitudinal, vertical, and then lateral directional, and then we have our thrust, forces, and moments. So longitudinal, vertical, that's going to be, let's break it down over here. Okay, so you can see here there is some inputs for each of these blocks for which we compute the different coefficients. So you have your coefficient of drag, pitching moment coefficient, CM, CL, coefficient lift, everyone knows that. You have to worry, this is some matrix multiplication stuff, but this is just going to be an overview of what we did. But yeah, so you can see it, just intuitively you can understand how everything works by the process of formation and direction of it, right? The magnitude and direction of information, that's how you kind of think about it and how you understand it. So what it's taking in is elevator position and stabilizer that drives these coefficients here that determines the amount of pitch you want. Also, that's how we calculate the amount of drag and lift. And yeah, so this is taking an environmental busbar, which we'll touch upon later, but let me quickly move on into here. Okay, so lateral directional is going to be the same thing. You're computing, remember, the aerodynamic non-dimensional stability derivatives. If you don't know what that means, then this video is probably not for you. This is assuming you kind of have a foundation in controls. So yeah, so that's that. Okay.